We now discuss the solution of a problem from the section coordinate geometry. The problem is related to the concepts of centroid and orthocenter of a given triangle. This question has appeared in the joint entrance examination main held on 29th June 2022 in the second shift. The given question is the distance of the origin from the centroid of the triangle whose two sides have the equations x minus 2y plus 1 is equal to 0 and 2x minus y minus 1 is equal to 0 and whose orthocenter is 7 by 3, 7 by 3. The ordered pair 7 by 3, 7 by 3 is. We are given four options. Option A, option B, option C and option D. Right. We are given a triangle whose two sides have the equations x minus 2y plus 1 is equal to 0 and 2x minus y minus 1 is equal to 0. And the orthocenter of this given triangle is 7 by 3, 7 by 3. And required to find the distance of the origin from the centroid of this triangle. We now discuss the solution of the problem in detail. We are given a triangle ABC with orthocenter H with coordinates 7 by 3, 7 by 3. This is your triangle. Right. How do we get the orthocenter? The orthocenter is defined as the point of concurrence of the altitudes of the vertex to the opposite sides. Right. So, we drop an altitude, that is BE, from the vertex B on AC, BE, and from C on AB. So, that is another altitude, CF. BE, CF, these two are sufficient. The point of concurrence is this one. This is H. That is the orthocenter given as 7 by 3, 7 by 3. Agreed. Agreed. And further you are given the two sides of this triangle as x minus 2y plus 1 is equal to 0 and 2x minus y minus 1 is equal to 0. We suppose let AB has this equation x minus 2y plus 1 is equal to 0 and AC has this equation 2x minus y minus 1 is equal to 0. Agreed. Now, what is wanted? Required to find the distance of the origin O from the centroid G of this triangle. Now, to obtain the centroid capital G of this triangle, we need to have the coordinates of the vertices A, B, C. And AB has this equation, AC has this equation. So, they intersect at A. So, the vertex A coordinates can be found if we solve these two. So, from the equations of AB and AC, on solving, if you solve these two equations, you will get the coordinates of A as 1, 1. Our target is to find the coordinates of B and C also. Once we get it, then the centroid will be there. Then the distance from the origin can be calculated very easily. Agreed. So our concern is to find out the coordinates of B and C. We will do that in the next slide. So that's our triangle. That's our orthocenter H 7 by 3, 7 by 3. The side AB, the equation is here. The side AC, the equation is here. The coordinates of A, we have already found 1, 1. Now, let us say, what will be the coordinates of B? So, B lies on the straight line AB. Agreed. Suppose you take y is equal to q, then x will be 2q minus 1. So, the coordinates of B, you can take it as 2q minus 1 comma q for some q. For some q, we have to find out. So also AC also. So for that, you take a x is equal to p, let us say. So then y will be 2p minus 1. So the coordinates of C will be p comma 2p minus 1 for some values of p and q which we have to determine. So agreed. So the coordinates of this vertex B, the coordinates of vertex C in terms of p and q we have found. So to find out the values of this one, we observe that BE is the altitude on AC. So BE is perpendicular to AC. So also BH is perpendicular to AC because BH is a part of BE. So we know the coordinates of H, B, these coordinates are there, and AC slope we know. So now slope of BH is same as slope of BE, and the slope of BE multiplied by slope of AC is minus 1 because BE is the altitude on AC. So how do we get the slope of BH? So the B coordinates are here, H coordinates are here. So y2 minus y1, 7 by 3 minus q by x2 minus x1, 7 by 3 minus in brackets 2q minus 1 multiplied by slope of AC. The slope of AC is 2, y is equal to 2x. Agreed. So that will be this one. Agreed. So it is a very simple exercise now. Take the LCM and somehow compute the value of Q. The value of Q can be easily found out. That will be Q is equal to 2. If Q is equal to 2, B is 2Q minus 1. 2 3s are 2, 2 2s are 4 minus 1, 3, and Q is 2. So the coordinates of B we have obtained. In a similar fashion, we also do CH. CH is a part of CF. CF is altitude to AB. So we will write slope of CH multiplied by the slope of AB, this AB, right? This AB is minus 1. And the coordinates of H are known. For C, we have taken this one. We write 2p 7 by 3 minus 2p minus 1, y2 minus y1 by x2 minus y1, p minus 3 into slope of AB. So the slope of AB is y is equal to 1 by 2x. Right. So this is the slope of CH multiplied by slope of AB is 1 by 2 is equal to minus 1. It's not 1, it is minus 1. It is minus 1. I am sorry. It is minus 1. It is minus 1. So solving for P, we will get P is equal to 2. And take the value of P is equal to 2. Substitute in the coordinates of C. That will be 2 comma 2P minus 1. 2 2s are 4 minus 1, 3. So the coordinates of C are 2 comma 3. I am sorry. Here it is minus 1. Minus 1. Please note down it is minus 1. Agreed. Thus, the coordinates of A, B, C are known. So, thus, the vertices of the triangle are A with coordinates 1, 1, B with coordinates 3, 2, C with coordinates 2, 3. And once we know the coordinates of the vertices, we have the formula of finding the centroid. So, how do we find centroid? Centroid is denoted by G. G will be given by the sum of the abscissae x1 plus x2 plus x3 by 3, comma, the sum of ordinates y1 plus y2 plus y3 by 3. The centroid G is given by this one, 1 plus 3 plus 2 by 3, 1 plus 2 plus 3 by 3. And this is 6 by 3, that is 2, 2. So the coordinates of G are 2, 2. So required to find the distance of the origin from the centroid. So the distance of the origin is 0, 0. From the centroid G 2, 2, and that will be under the square root of 2 minus 0 whole square plus 2 minus 0 whole square, that is under the square root of 2 square plus 2 square. that is equal to under the square root of 4 plus 4, that is under the square root of 8, that is equal to 2 root 2. That's our answer. Let's look at our options. Our answer 2 root 2 appears against option C. Therefore, the answer to this question is option C. That is the detailed discussion of the solution of the problem from the section coordinate geometry, and the problem is related to the concepts of centroid and orthocenter of a triangle. It is definitely a good question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.